Okay, so we're looking at more nets and more surface area in this lesson. So we're going to draw some nets. Remember, nets are the flat versions of what you fold up together to make a polyhedra. We're going to talk about those to find surface area. So today we have our two I can statements. I can calculate surface area of prisms and pyramids, and I can draw the nets of prisms and pyramids. So make sure that you've got both of those down before you move on. So let's take a look at a real world problem here. Some wrapping paper. With wrapping paper, this is actually something that you do need to know a surface area to make sure that you have enough pieces for. So I have this box here that Kieran is going to wrap for a friend for a gift. And so if we look at it, we've got rectangles on the front and the top, which means that our back side is going to be a rectangle and bottom is going to be a rectangle. Over here on the side, we actually have a square. And I do know I've got one of the measurements I need to know, and I've got another one, but I don't have this. If this is a square, though, then this needs to be what? Yeah, 2 5/10, or 2.5. Now that I know this, I'll be able to find all of the area of all of it, right? How do we find the surface area again of some three-dimensional figure? I hope you chose to say that it's find the area of each face and add all the faces together. Well, I've got one face here, which is 4. And I've got that times a height of 2 5/10. Now, when you're finding it, you may do this differently, but if I know one of these, isn't that the same as the other 4? Mm-hmm. And then the end is a square, and we need 2 of those. So enough hints, try and figure it out on your own. What is the total surface area of this box? So you've got yours entered. Let's take a look. Like I said, I was going to do that 4 times the 2 5/10 for the one side. And I'm going to just take that times 4 because I've got 4 of those. And this 2 5/10, I need 2 of those, so I'm going to double whatever I get here. So 4 times 2 5/10, let me put a different color here. Well, let's see, so I'm going to do 2 5/10 times 4. 4 times 5 is 20. Carry the 2. 4 times 2 is 8, plus 2 makes 10. I've got one digit to the right. Tenths times a whole number, so that means I should have just 1 here. That should give me 10. I've got 4 sides that are the same, so that means I've got 40 square inches around the outside. And then I have 2 5/10 times 2 5/10. Remember that with decimals, you're not worrying about the decimal until the very end. 5 times 5 is 25. 2 times 5 is 10, plus 2 more makes 12. 2 times 5 is 10, carry the 1. 2 times 2 is 4, plus 1 more makes 5. So I have 6, 2, 5 as my digits there. I have tenths times tenths. Well, tenths times tenths, or 1 over 10 times 1 over 10, gets me 1 over 100. So that means that my answer is 6 25/100. One place to the right, one place to the right, so my answer has to have 2 to the right. I have to double this. That gets me 10, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 6 is 12. 2 places to the right, 2 places to the right. So that means I need to add 12 and 5/10 or 50 hundredths. Now, I want to make sure that I've got this 12 should line up exactly underneath that 40. This 5, to help me out, I may draw a 0 here at the end, but I really don't need to. And that kind of looks like something crazy. But remember, when you're adding or subtracting decimals, you have to line up those place values. So the 0 and the 2 are in the same place value. The 4 and the 1 are in the same place value. This 5 will just have a 0 over it. So if I've mathed correctly, I should have 52 and 5/10 square inches. So at 52 and a half or 52 and 5/10 square inches, now I know what the area of the wrapping paper needs to be at bare minimum to cover my entire space. So can we do the same thing with a pyramid? Well, I've got a pyramid here. Oh, let me adjust this just a shade so you can see the entire picture a little better. There we go. So when I look at this one, this should be the same sort of thing, right? I'll need to find what to find the total surface area of this one. Yeah, I'm going to need to find the areas of each of the triangles and the area of this center square space. So finding the square is pretty easy, but finding the triangles, it's not quite the same, is it? Yeah, remember with the triangles, you're going to take whatever the base is, whatever the height is, multiply those together, and then divide by 2, right? The center part's easy. We just have to multiply the length times the width. Okay, so find the area. Great. So for a base on the triangle here, I've got 1, 2, 3, 4, 5, 6. Oh, so that means my square space inside is 6 times 6, which gets me 36 for an area inside. And then I have my triangle is 6 for a base, and then I've got 1, 2, 3, 4, 5, 6, 7. 7 times 6 is 42. And that would be just for one, or that would be more than one of those triangles. So I actually need to divide this by 2, which should get me 21. I have 4 triangles, so I take that 4 triangles times the 21, which gets me 84. 84 plus that 36 from earlier. It's going to give me a total area of, carry the 1, should be 120 square units. Always remember that these triangles, you're going to find whatever their base times their height is, and our heights were right through here, right? Because you want that perpendicular line from the base. Well, actually perpendicular, not wavy like that one was. And if you've got that perpendicular height from from the base, then you take the base times the height, divide it by 2, and that gets you your area. So we had 21 for each of those, 84 total, and 36 total there. Take a look at these. If we were going to compare all of these nets for making cardboard boxes, we could take and find each of the areas and figure out which of these use the most cardboard, which one should use the least, and figure out their surface areas. Wouldn't be too difficult, would it? Well, think. What would be the what would be the area of this one piece here? We got a 2 by 3. Yeah, that would be a 6, wouldn't it? 3 times a 3 would give us 9. Okay. So this is the same as that one. So that's another 6, another 6, another 9, and another 6. 6 times 4 is 24. 24 plus 9 and 9 makes 18. Gives us a surface area of 42 square centimeters. Same sort of thing here, right? 3 times a 6, we get 18. We get 18 here, but here I've got 1 by 6. So this is 6. This is 6. 3 times 1 gets me 3 here and 3 here. So we have 6 and 6 being 12, plus 3 and 3 makes 6, plus 18, plus 18. So it's 8, 16, 16 plus 8 is 24. Carry the 2. That makes 54, right? Figure out the surface area of C. Yeah, 3 times 3 should have been 9. So once you find 9, then all of these are 9. So you have to just take 9 times 6. That gives us 54. So which way is going to be the way that's going to give us the fewest or the least amount of cardboard? Yeah, A is actually going to be the least, right? Is that going to be true for its volume? Because we want to get the one that holds the most in it. So A had the least amount of cardboard. Which one's going to have the least amount of volume? Well, I've got 2, 3, and 3. So 2 times 3 is 6 times 3. So this one's got a volume of 18 cubic centimeters. Here I've got 3 times 6 times 1, 18 cubic centimeters. 3 times 3 times 3 is 27 cubic centimeters. So even though these two have the same surface area, this one can hold more. And even though these two end up making the same, or those have the same surface area, this one actually can hold more because of the way it's laid out. And then the opposite is true here. Even though this has got a small area, or a smallest area, it does hold as much as this. So this would be the most wasteful version to make, wouldn't it? Yeah, because then you end up wasting quite a bit there. All right. So this final one makes a cube, because those are all equal measurements. I want you to draw a cube net of your own. And then I want you to draw another one. And draw another one. Yeah, draw at least 3. But what do you know about all 3 of those? They all have the same length, width, and height. We can make a bunch of these, right? But I want you to get at least 2, actually 3 examples drawn in your notebook. Just do the best you can with that, okay? And I'd love a picture. All right. So we were looking at calculating surface area on prisms and pyramids. We need to remember that base times height and then divided by 2 is what we use for triangles. And we need to remember that for squares and rectangles, we have to use the length times the width, or the base times the height. No dividing there. All right. Nice work. Have a good one.